Hello guys, this is Sci-Chem. In this video, I'm going to teach you how to do blind docking. In some targets, in some proteins, you do not know the binding site. You do not know where your ligand would attach and bind. Uh, this form of proteins are called apoforms. You can check this in PDB website. If you scroll down, there's no place that you can see the macromolecule and a small molecule. The macromolecule is just the protein, but the small molecule is not found in this page. So we can find out that it's apoform, and we don't know where the drug or ligand would bind. So first of all, we download this file and see it viewer light. This is our structure. It has two subunits. We are using the A subunit. It's not important. And we would save it as our receptor. So, and for our ligand, what should we do is uh, use a drug. It's not important which drug. I'm going to use aspirin. Save it as mol file L, and here save it. Okay, then I'm going to open Chem 3D and turn this 2D structure into 3D structure. Open. So I'm using calculations mm2 and minimize energy. Okay, now it's done. Now I should save it as PDB format in my folder. I should copy these two files into my folder because they are essential for doing molecular docking. Before doing the molecular docking, I should open viewer light and open my ligand to know the coordinations of the center molecule. I'm going to assume this one as um, center, and I should write down the coordinations. That's okay. So let's do molecular docking. The molecular docking is the same about those dockings like protein and drug interaction or validation. It's just a little difference. I'm going to describe it a little later. So the steps are similar, are edit, add hydrogens, check charges, good. Now hydrogens merge nonpolar, continue. File, save as, write PDB. PDB. Yes, replace it. Okay, overwrite. Now ligand. Open. PDB format. L. Okay. We can see here our drug or ligand is out of the receptor, but it's not important. So next, grid, choose R. Okay, save it here. Grid, set map types, choose ligand. And this is the most important part about docking. So I told you a little earlier that you should write down the coordinations of the center atom of your ligand molecule. But no, in blind docking it's not important. Why? Because you don't know the coordination of the active site, and you should figure it out. How should figure it out? Your grid box should contain all of your receptor, because you don't know exactly where your active site is. So you should select all the receptor into the grid box, and after doing molecular docking, after calculations, it will tell you where would the drug or your ligand attach perfectly. So here there's a spacing. If you can lower or higher it, we are doing 1 is the most, and here we can expand it. You should expand it that all of the receptor would be contained in your grid box. Okay, and for the last, that's okay. You see, I have selected all my receptor into the grid box. So after doing so, your drug, your ligand would check your receptor and see where it can attach or bind the best. So close saving current, output. The rest is like other molecular docking methods. Docking, ligand, macromolecule first, R file. Ligand, open, ligand. Accept docking. Genetic algorithm, we use 50 runs. Docking parameters, the third should select customize step size, and output L'American GA, and save it as r.dpf file. And at the last, you should open your CP or command prompt and write this sentence: cd desktop, cd the name of your file, that our file was blind. Okay, now we should wait until it's completed. Sometimes it can take a while because your grid box is really huge, so it's not surprising that it would take some time to process that. Okay, AutoDock. And this is it. Now we can open our folder, and like previous two videos, there's a file called r.dlg. You can open it and see how your docking is going on. Scroll to the last and we can see here that it is working and 50 runs should be done. So now we should wait for our multiple docking to be finished and analyze the results. So our docking has been finished and we can open our file r.dlg, then see what happened. So we can see that successful completion, and we should go up, see what happened. So this means our clusters are lot. Okay, our first cluster rank we can see with 9 clusters from 50 had the mean binding energy of minus 4.6. We can see that somehow our ligand has been binded to our receptor. It wasn't great, but it was not so bad. And we can see that our ligand or drug found a way to attach to our um, receptor, and from using our ligands coordination that has been attached in these 9 clusters, we can somehow find out the coordination of our actual active site in this receptor. So this method, blind docking, can help us with proteins, for receptor, enzyme, anything that has not cognate ligand and it's just the pure protein. This is it. Hope you enjoy it, and like and subscribe. Bye bye.